well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 100 is on the screen. Let's get started, please. Shouldn't take you long. Go. Once again, agenda, warm-up number 100, rational functions. Home plate for tonight, 394, 395 evens. Last night were odds. So hopefully, today I'm just going to walk you through a couple of things just to make sure we see some very important things in regards to the graphing portion. All right? So we're going to go over some of those home plate problems here in class, so hold on to that really quick. Get a Cornell note ready, please. All right? I can solve and graph rational functions. I can solve and graph rational functions. So we don't need a fair model today because we already know what rational functions are. Yes? Yes, Mr. Q. All right. Tell your neighbor what rational functions are without looking at your notes. So like that, Jaden can give the definition. Rational functions are, in your own words, Jaden? Man, almost like from dictation. Yes, an equation with one or more fractions in it. All right, good. That's why we don't need a fair model. Then we followed these steps last night for the home plate, yeah? Gave you guys a general rule. Talked about asymptotes. We said these were the horizontal and vertical asymptotes. We did some of these. Write this down, functions. I want to revisit parent functions, so write this down. Functions, on the left side, I want you to write parent function. Parent function. Here goes the first one. F of x equals x. And here's my graph. Next one, f of x equals x squared. F of x equals x cubed. F of x, and so on and so forth for polynomials. I'm just going to write x to the fourth. And that graph is kind of like the parabola, but I'm going to elongate it from the bottom a little bit so that we know it's a polynomial function. And now we are in f of x equals 1 over x. Now it looks like this. All right. So far, so good? Yeah? Those look familiar? Yes? So, then by now, you should know what 2 points are on all the parent functions. Think about it before I pick someone to answer. Think about it. What 2 points are on all parent functions? Talk it over your neighbor. What 2 points are on all parent functions? All right. Give us 1 point. Jaden. 0, 0. Yes. 0, 0. 0, 0. 0, 0. 0, 0. And 0, 0. There it is on the asymptote. Plot it in there, please, on all of them so you can know that 0, 0 is on there. Now right over here on the top, 0, 0. All right? Tell your neighbor one more point. What one more point is on all parent functions? Jaden, pass someone. JP. 1, 1. Plot it there. 1, 1. 1, 1. 1, 1. 1, 1. And check this out. 1, 1. That is correct. On all of them. 1, 1. All right? Now check this out. Look what I'm going to do today. I'm going to give you the general rule. Don't write this down. That rule applies to all of them. The only thing it changes because for this one we put a squared, yes. For this one we put a what? Cubic. For this one a quartic. For this one we put that under 1 as a fraction, but it applies to all of them. So, if that is true, check this out. If I was to substitute for h, give me a number. 7, okay. And for k, I substitute -3. All right, think about that. Don't write it down. If I substitute 7 for h and for k -3, tell your neighbor where I'm going to move all of the functions. Why all of them? Because they all have what 2 points? 0, 0, and 1, 1. So tell your neighbor where we're going to move all of them to, please. Jaden. 7 to the right and 3 down. Hands, have you got that? Or in other words, what's our new vertex, everyone? 7, -3. That is correct. So I can take, watch, look what I'm going to do with my technology. I'm going to take all of the functions. Oh, except this comma. There you go. I'm going to take all of the functions and move them 7 to the right and 3 down. You're like, what? Oh, yeah. Straight up and down like that. And you'll notice that I move the rational including all the asymptotes. Yes, they all move together with the entire function. Is everybody following along, yes? All right. So far, so good. Trying to get your transformation goggles on. But before we move it, check this out. What if I change that to that? Ooh-wee. What point is going to change on all of them? Talk it over to your neighbor. What point is going to change on all of them? Let's see, let me pick someone new. Jaden, go. What? What point is going to change? There's only 2 points, 0, 0, and 1, 1. Which one is going to change? 1, 1. And what's that going to change to, Jaden? Instead of 1, 1, it should be 1. Whoo-wee. Let's see. 1, 2. What does that do to the function? It stretches it. Let me do that to this one. 1, 2. 1, 2. 1, 2. 1, 2. Yes, it's going to stretch all of them. So far so good, yes? Is everybody following along pretty good? Yeah? All right. Get your home plate in front of you, please. Let's go to the home plate. The previous class, they told me to go over number 11, but let me go to the top, see if there's anything in the first four that you want me to go over, so you can see the entire process. So last night were odds. You want me to go over 1, 3, 5, or 7? Or do you also want me to go over 11, or what? 7? Okay. Before I do, though, look up to the screen. Look at number 9. All right. Let's see. Now that we have our transformation goggles on, let me give you the parent function for this one. Don't write this down. There's my parent function. Tell your neighbor we're going to move this to according to that. Where are we going to move this? Because this is the parent function, isn't it? 1, 1, yes. And here's 0, 0 in between, okay? So where are we going to move that, which is that one, according to that? All right, let's see. Jaden. One to the left, yes. And then 2 down. But before we do, tell your neighbor what this is going to do to one of the points, please. And mind you, I'm going to give you the point. It's right there. 1, 1. Jaden. So our new point is going to be what? Let's go, let's go. So my new stretch point is 1, 3, and this one -1, -3. And now we can move those 2 points where? 1 to the left and 2 down. So let me move that 1 to the left, 2 down, 1 to the left, 2 down. And now my new graph is here and up here. Oh, my bad. And right there. Man, I love technology, right? Am I right? Am I right? All right, so with that said, just wanted to show you that really quick. So you said number 7? Or number 11? All right, 7. Let's go to 7. All right, so here goes the entire process. Ready? So, finish this easy one, and then we'll move on to more challenging one. Here it goes. So you hear the very first thing you do when you get to this. Very first thing. Go, Jaden. Very good. VA equals HA, Y equals. So, what is our VA? And our HA? 0. Yes, let's plot those and graph those. X0 is right here, straight up and down. Y0 is there again, side to side. What do we do next, everyone? Everyone. Table. What values do I use for X? tell your neighbor before Jaden shares and why you're using those values. All right, go. What is it? -2. All right, why did you choose those? Let me give you a hint again and again, because last time you said to give you another hint. There it is. He picked 2 on the left and 2 on the right. That means he gave me -2, -1, 0, 1, and 2, and everybody writes what for 0? Undefined. That is correct, because that's our asymptotes. All right, so I'm going to write this. Now check this out. Isn't this a fraction? And this is a decimal. So what would be easier, changing this to a decimal or changing this to a fraction? Yeah, to change this to a fraction. So that's -1/10 times 1 over blank for the x. So what goes in the blank, everyone? -2. So negative times a negative, positive, 1 over 20. Man, this is easy. Come on. Next, -1/10. What's my next value? -1. So what is 1 over -1? -1 times 1, -1/10 is 1/10. Next, what is 1 over 1? 1, that's -1/10. And last but not least, -1/20, yes? All right, let's plot that. -2 1/20th. -2 1/20th is very close to the asymptote right there. -1 1/10, -1 1/10. And I'm going to put my +1 over here and -1 over here. So like that, you guys can see this is a fraction. -1/20th, -1/10. I'm going to graph that. All right, this one. 1 -1/10, 1 -1/10. 2 -1/20. Now, some of you might be asking, Mr. Q, if you only have 2 points and you start graphing it, why do you curve it? Why do I curve it like this, guys? And here goes another hint. Here it goes again. Tell your neighbor, why do we curve it? Let's see. Jaden. You ever hear that? He said because we cannot touch or cross the asymptote. It's an invisible force field. It's repelling the graph and moving it away from it. I can't go through it because there's an invisible force there. That's where it starts curving away from it. One more, or are we good? Yeah? No? All right, we'll stop right there. However, once again, for tonight's home plate, you're going to be doing all evens, which is exactly the same process. HAVA, get your table going, and then you'll go from there. Okay? Thank you, Mr. Q. You're welcome. I'll stop right there. Bye.